So, my name is Michael Rabalais, and I'm here today to give you a short talk on mechanical seals for rotating equipment. So, what is a mechanical seal? If you're like me and you're not really familiar with them, you might think it's something like what's in the top corner of this photo. You're about half right, but not quite. This is actually a diagram of a mechanical seal. Just a little background into my experience with them. During my first internship, I started, and one of the first projects they gave me was to upgrade a seal for a specific pump. And my mentor came to me and was like, here's this drawing, get this project done. And I was like, well, what am I looking at? This looks pretty complicated and confusing. And that's kind of why they're prevalent through all industry, and as mechanical engineers, if you go out into industry, you have a pretty good chance of running into mechanical seals or working on them yourself. So I just kind of wanted to come and give you a little background into them. So they've been used since the early 1800s. They were very simple then. However, in the last probably 30 years, the advancements in manufacturing, advancements in materials, as well as strict regulations for emissions have caused the seals to become more advanced. It's a device that's used to seal the outside environment from what's the internal working fluid, pumps, compressors, blowers, things like that. And you have a shaft that's running from, like, say, an electric motor into your piece of equipment. You have to have a way to prevent your atmosphere from interacting with your working fluid. So how do they work? Basically, the seals are composed of a few different pieces. The yellow here is going to be your rotating face, and stationary faces in the orange. That's your primary sealing surface. These two faces have to be flat within 11 millionths of an inch, so they're pretty difficult to manufacture. Basically, what happens is your process fluid is here in the blue. Say in a pump, it's around like your suction pressure of your pump, and your sealing fluid is going to be the red. It can be the same process fluid you're using or a different buffer fluid. And essentially what happens is you have a spring force that keeps your two faces basically in contact with each other. However, you have fluid that leaks between them to keep those faces cool and lubricated. You would think, being a seal, you wouldn't want it to leak, but all seals must leak to be able to operate properly. In ideal operation, your red fluid would leak towards the blue and keep all of your process fluid inside of the pump. Some of the essentials for the seal operation, they have to be flat and polished, they must be aligned properly, and the spring force must be sufficient to keep the faces in contact. Of these three, the most difficult to do is the flat and polished. So here's like a little example of something that, like, if you turn it on a lathe, you might get 10 micron roughness with it, which is pretty good for most signature manufacturing. But for the seals, they have to be down to the half micron level, because over here you get less than 5% contact between the two surfaces. And whenever you bring it down to half micron, you get up to 95% contact. I've actually seen it. They've properly polished seal. You can take the two faces and put them together and hold it, and gravity won't pull them apart because they're stuck together so well. So as an engineer, whether you're designing a seal or you're as like a project role and you're trying to select what seal you think applies for your application, there's some important things to consider. Some of the different sizes of your pumps or your shafts, temperatures and pressures that you're working with. But really the most important is the fluid characteristics that you're trying to seal, whether it's a clean lubricating fluid like a motor oil or something that you're moving, or something like corrosive like a hydrofluoric acid, whether it has embedded solids like a slurry. All of these will change the type of seal that you use, as well as if it needs to be a single seal or double seal, or if it needs to be vented to like flare. So just to go through a few of the seal types that you might see that are pretty common. One of the most used is a type 11 or 13. Basically, they use the fluid that you're actually working with, pull it from either the discharge or the suction of your pump, and it goes back into the gland. It's basically just used for heat removal inside your seal chamber to make sure that your pressure is high enough that you don't actually have a phase change with like a lighter hydrocarbon. You can see a phase change whenever it gets into the lower pressure. It's a pretty general application. The Type 21 is very similar to the 11. You just use a cooler. Basically, you're still pulling your same process fluid. However, it might be at an elevated temperature that whenever you go down into your lower suction pressure of your seal, you have the chance of flashing. So they use a cooler just to bring it down so that your vapor margin is a little better. Both the Type 21 and 11, your process fluids have to be clean and non-corrosive because you're just using that same process fluid to lubricate your seal faces. A little bit more advanced one would be a Type 32. You bring an external source into your system and use it to clean the faces, like if you're using like a very corrosive or dirty process as your fluid. And the last two is a 52, which is a secondary seal. This one, as well as a Type 72, 76, have been developed due to your higher regulations for emissions. So basically, it's a secondary seal that would be applied to like a Type 11 for like a light hydrocarbon that might change phase and be released to atmosphere. Something that they monitor very heavily with the EPA. So, any questions?